we are going to discuss two major examples. Number one, I give you a general term, you list the first 5 terms of a sequence for me. And then the second example, I will give you a sequence and you have to tell me the general term an. Alright, so first of all, we have an equals to 2 to the n divided by 2n plus 1. Can you write the first 5 terms for me? So the first 5 term, when a is equals to 1, so n is equals to 1, right? We have 2 to the first divided by 2 times 1 plus 1, so that is equals to 2 divided by 3. When n is equals to 2, we have 2 to the second, and then 2 times 2 plus 1, so that is 4 divided by 4, 2 times 2. 4 plus 1 is 5. A is equals to 3. 2 to the third. 2 times 3 plus 1, that is equals to 7. 2 to the third is 8. And then a to the a fourth, that is 2 to the fourth, which is 16. And then 2 times 4 plus 1 is 9. So we have 16 divided by 9. And then the a to the fifth, we have 2 to the fifth divided by 2 times 5 plus 1. The bottom is 11. 2 to the fifth power is equals to 32. So that means the first 5 terms of this sequence is 2 thirds, 4 fifths, 8 over 7, 16 over 9, and 32 divided by 11. Alright, and then you can keep moving, so I will just write ... so you can keep on moving. You can write A6, A7, A8, A9, A10, so on and so forth. Now, how about this? The other one, we have A1 equals to 1, so the first term is equals to 1, and then the next term is equals to the nth 5 times the nth term minus 3. So when n is equals to 1, what do we have? When n is equals to 1, we have a to the a1 is just equals to 1, so you plug in 1 to this n, right? So that will be 1 plus 1 equals to 2. That equals to 5 times a1 minus 3. So 5 times the previous term minus 3, which is 5 times 1 minus 3, right? That is equals to 2. So a2 is equals to 2. When n is equals to 2, we plug that into the plus 1. So 2 plus 1 is 3. That is equals to 5 times a2 minus 3. So that is equals to 5 times a2 is equals to 2 minus 3. 10 minus 3 is equals to 7. N is equals to 3. 3 plus 1 is 4 times 5 equals to 5 times a3 minus 3. So that will be 5 times 7 minus 3 equals to 32. And then n is equals to 4. I write n1. N is equals to 1, equals to 2, equals to 3, equals to 4. So we have a subscript 4 plus 1, and then 5 times a subscript 4, right? So a4 minus 3. A4 a equals to 4. Three and then 4. So 1, 2, 3. Did I make a mistake right here? So when n is equals to 4, we have a4. Hold on. So n equals to 1. 1 plus 1 is 2. N equals to 2. 2 plus 1. N equals to 3. 3 plus 1. N equals to 4. 4 plus 1. Did I make a mistake in anywhere? Because I don't have come on. We do. We have a4, that is 32. So that will be 5 times 32 minus 3. So the 7 is right there. And then that is equals to 157. And then when n is equals to 5, we have a subscript 5 plus 1 equals to 6. And then 5 times a subscript 5 minus 3. So we have a5. So that is 5 times the previous answer. And then minus 3. Minus 3. Oh, actually, we don't need to do this one, right? Because this, we already have a1. Okay, we wrote it down already. Let's find it anyway. 5 times 157 minus 3 equals to 782. So actually, we got the first 6 terms. So the first term is 1, and then 2, and then 7, and then 32, and then 157. That is already enough for the first 5 terms, but we did an extra. Okay, let's write it down anyway. 782, and then we can keep on going. So this is how you use a general term to write a sequence. All right. In the next example, I will give you a sequence, and then you have to tell me the general term. That problem, depending on how good your number sense is. So let's go take a look. The next problem, I will give you a sequence. So let's say number 1, I will give you a sequence. The sequence is 1/2, 1/4, 1/6, 1/8, 1/10, and then we keep on going. Can you tell me what the nth term equals to? So here we have A1, A2, A3, A4, A5. So n equals to 1, n equals to 2, n equals to 3, n equals to 4, n equals to 5. So that means based on this pattern, if I want to look for a specific term, can you tell me what the general term is? So that means look at this list. Can you tell me what the pattern is? This really tests your number sense. So the first term, the 1/2, is 1 divided by 2 times n. And then the next term is also 1 divided by 2 times n. What do I mean by that? 1/2, right? 1 divided by 2 times 1 is just 2. And then this n is the second term, right? So when n is equals to 2, I get a 4, and then the rest, they are all 1 divided by 2n. And so on and so forth. That means the overall pattern is 1 divided by 2n. So when n is equals to 3, we have a 6. When n is equals to 4, we have an 8, right? So that means overall, an is equals to 1 divided by 2n. So that is the general term. So this is a general term. What does the general term represent? The general term explains the pattern of the sequence. So this explains the pattern of this sequence. Let's do one more. The next one is harder. So the next one, we have number 2. We have -3, and then 2, and then -4/3, 8/9, and -26 divided by 27. And then we keep on moving. So this one is a lot harder. First of all, do you see that the negative alternates, right? So the negative alternates. What does that mean? So that means when n is equals to 1, we have a negative. N equals to 2, we have a positive. 3, negative. 4, positive. 5 is negative. So when n is equals to an odd value, the term is negative. So here is how I do it. So we will start with a -1. This is the strategy that you have to learn. We will be using -1 as a base, and then we put an n in there. So when n is equals to 1, we have negative, right? When n is equals to 2, we have a positive. So when the exponent is odd, the value is odd. When the exponent is even, the value is even. So that's the first thing that you have to learn. And then other than that, what else do you see? So here is what I see. So a1 is equals to -1 to the first power based on what I just wrote. And then how do you get a 3? Easy. You just multiply by 3. So you get a -3, right? And then a2, I know this is not easy to see, but this is a skills that you have to learn through doing homework. You can't just do one problem and expect to be able to do everything, because every single sequence is different. So if you see a problem like this on a test, maybe that will take you like 15 minutes to figure out what the sequence is. So to get more experience, you have to do your homework, and hopefully the one you see on a test is not too difficult. All right, and then the next term is we have -1 to the second power, and then how do you go from a 3 to a 2? So here is how we take a 3 times 2/3, and then raise to that is a 2. So this is a 2 raised to n minus 1. So when when n is equals to 2, 2 minus 1 is just the first power, right? And then 3 times the fraction is just equals to 2. And then a3, and then negative 1 to the third. So this will be 3 times 2 thirds. Is that still work? Yes, when n is equals to 3, first we have a negative, and then second, 3 minus 1 in the exponent is equals to 2, and then we have 2 over 3 raised to the second power times 3. This one you get a negative 4 over 3. So that means overall, the an is equals to first negative 1 to the nth power, and then you have a 3 multiply 2 over 3 raised to the n minus 1 power, and this is a 2. Alright, so that is the overall pattern of this sequence. I know it's not easy, that's why I picked this problem to discuss. To get more experience, you have to do some homework. Alright, and you should hope that on the test, you won't get such a difficult sequence that you have to figure out the pattern. Alright, so that will be the end of this video. In the next video, I will introduce more concept, and then after that, we will do more exercise. I see you all in there. If you think this is helpful, like, subscribe, and share. Appreciate your help. Signing out for now. See you in the next one.